Hello everyone. So in this video we are going to discuss two questions from JEE Main PYQ. So the first question is from indefinite integration, and this question was asked perhaps in 2023 or 2022. And the second question is from the chapter determinant, and in particular system of equation, and that question was from 2023 perhaps. So these both questions I'm going to solve in an unusual way, and we will see how to do it. So the first question I'm taking is the integration one, and here is the usual or natural way to proceed, and this is a solution I have already written just to explain that how it is lengthy and how we can avoid this solution and solve it smartly. So first, how the solution look like, the usual one, is the question is this one first. The question says that I have to find out the integral, and the numerator I have as 1 minus 1 by root 3 cos x minus sin x, and the denominator I have 1 plus 2 by root 3 sin 2x dx. And after this integration you have to write the answer in one of this form, means tan x by 2 plus pi by 12, tan x by 2 plus pi by 6, and so on. So the idea is very simple. Whenever I see cos x minus sin x in the numerator and sin 2x in denominator, I can write this sin 2x in the form of sin x plus cos x, so that sin x plus cos x can be assumed as t, whose derivative is cos x minus sin x, which is already present in the numerator with dx. So I'm substituting sin x plus cos x as t, so of course I will get the denominator at the place of sin 2x as t square minus 1, and at the place of cos x minus sin x in numerator I can write dt, combining with like dx. So here 1 minus 1 by root 3 is a constant, I can take it out, and I have this dt by 1 plus 2 by root 3 t square minus 1. After simplifying further to get the standard form of a special line integral, I can write 2 by root 3 t square, and I combine this 1 and minus 2 by root 3 together. Now here understand that the idea that this thing is 2 by root 3 is a number lesser than 1. So I should write in this way that the minus should be visible. Otherwise, many students did the mistake that they take the plus sign here, 2 by root 3 minus 1. Then what will happen? They assume that this is positive and this is again a positive quantity, and they end up with the tan inverse x formula. But it's not the case. We have to be very careful because 1 minus 2 by root 3 is a positive quantity. So we take the minus 1, minus here, and so this will give you t square minus 1 minus root 3 by 2. And after simplifying all these things, and finally t square minus this quantity, so x square minus a square format, and then we get this thing, and after some further manipulation we will end up with this tan x by 2 pi by 12 in the numerator and then denominator and so on. So this is the lengthier solution, but can we do better? If we can do better, how? We will see it. So here is this question again, and I'm going to solve it from scratch, no prior any written thing. So you can notice that I'm writing here that 1 minus 1 by root 3 and cos x minus sin x, and denominator I can write root 3 plus 2 sin 2x by root 3, and this is dx. You can notice that this root 3 I can cancel with this one. What I mean to say is this root 3 I can cancel this with this root 3. So what I'm getting there in the numerator is root 3 minus 1 cosine x minus sin x, and denominator I have root 3 plus 2 sine 2x. Now the aim is to find out in terms of tan, so why not we can think in trigonometric form smartly. So how do we think? Let's see. What I'm going to do, that I am multiplying this thing, and before that I'm dividing the numerator and denominator with 2. So this will give you root 3 by 2 minus 1 by 2 at the first bracket, and here I have cos x minus sin x, and in denominator I have again root 3 by 2 plus 2 sine 2x, and here dx. So further what we can do, that I'm just multiplying, and it's expanding, so what we get it here, root 3 by 2 cos 2x, cos x rather, and root 3 by 2 sin x. There also minus half cos x and plus half sin x. In denominator I will have this root 3 by 2, so I'm writing there, that is not 2 because I've separated this, so this not should be 2 there, that should be only okay, so let me correct it, that should be sine 2x. Alright, because I'm dividing by 2, so that is the case. Now here root 3 by 2 I'm writing as, let's say, sine 60. So sine pi by 3, and this is sine 2x. Now what I get is this one. I'm combining this two together. My aim is to write in terms of sine. To achieve this thing, I am writing at the sine formula. So how do I write it? This is actually going to be, this I'm assuming, as you can see, this is root 3 by 2. I can take it as sine 60 cos x minus cos 60 sin x. So this will lead us to sine of x plus 60. And here from there I can take this minus sine common, and again I'm writing sine, so I can get sine. Now this time sine x cos 30 minus cos x sin 30, sine x plus 30 degree. So first aim, I'm taking that everything in terms of positives. No angle is taking any x minus or something. Even though you do mistake, you can manage it because sine and cos can be convertible to each other. Now here I'm writing sine c plus sine d formula. So we get 2 sine c plus d by 2. So that will give you pi by 6 plus x. And then cos c minus d by 2, that is x minus pi by cos c sine c plus d by 2 and sine c minus d by 2. So that is cos x minus 6. All right. Now, what is the idea? That you can see that here I have this value in terms of sine here. So if you separate it, this will get cancelled with this one. But the problem is there's a cos, and I want to cancel here. So I can again convert this cos into sine. So you can see I will write here sine x plus pi by 3 minus sine x plus pi by 6, and denominator I'm taking half out, and this cos I'm writing in a different way in terms of sine. So this is pi by 6 plus x, or x plus pi by 6, doesn't matter. Now you know that the sine of pi by 2 plus theta is again cos theta. There's no negative sign in front. So this I'm writing as sine of, let me just indicate what you want to say in blue. what I mean to say here, I'm indicating sine of pi by 2 plus theta is cos theta. So why not we can write this cos theta in reverse order. Cos theta I'm writing as sine of pi by 2 plus theta. So once you write it, you get sine of pi by 2 plus x minus pi by 6. So this will give you x plus pi by 3. And that's the target. So I'm getting sine of x plus pi by 3 there. And you notice now, once I separate it, I will get here this time sine x plus pi by 3 and sine x plus pi by 3 cancel. So I get here integration of cosec x plus pi by 6. And the second time, I have the second part, that is x plus pi by 6 will cancel. So I'll give you cosec of x plus pi by 3. Now it's easy to integrate now. This is half, and I have this integration as log of cosec, let's say I'm calling it alpha for convenience, minus cot alpha, and here I'm getting log of, let's say this is beta, so cosec beta minus cot beta. Now you know that it's easy to convert into cot, because this is 1 minus, in numerator I have 1 minus sine alpha by cos alpha, 1 minus cos alpha by sine alpha, and here also 1 minus cos alpha by sine alpha. So this will be directly tan of alpha by 2. So this will be directly tan of alpha by 2. It means I can write here tan of x by 2 plus pi by 12. And there also you can see this is again same thing. So tan of the half of this angle, that is x by 2 plus pi by 6. And when we apply this log property, by the way, log is there in every situation. So when you apply this log property, I can write half of log of tan x plus pi by 12, x by 2 plus pi by 12 divided by tan of x by 2 plus pi by 6. So this is not so difficult, and you can use in this way to solve this question. It's actually shorter and also the smarter one. Now let's go to the question what I am talking about. That is the question, this is 2024 by the way now, and this question is here, let A be a 3 by 3 real matrix, and they have given there's one correction I have to make here, that will be 1. So they have given this thing that I have A times 101 is equal to 2 times 101. Again, the second equation is A times minus 101 is equal to 4 times negative 101. And again, third one is A times 010, 010, yes, and 2 times 010. And they're asking the system A minus 3i, x, y, z, 1, 2, 3 has a unique solution, exactly 2 solutions, no solutions, symmetrically many solutions. So the natural way is that we will assume that the matrix A is going to be, let's say, A, B, C, D, E, F, and G, H, I. And after that, we just take in consideration all these 3 equations one by one, and we get a relation between A, B, C, D, E, F, G, H, and I, like 3 equations, 3 variables. And from there, we find out the values of A, B, C, D, E, F, G, H, I. It means we found the matrix A, and again I find A minus 3i, the matrix, and if the determinant of this A minus 3i is non-zero, we can say is a unique solution, and so on. But the task is very tedious because I have to find out A, B, C, D, E, F, G, H, and G, H, I. Can we do smarter way? So let's see how we are doing. So first of all, understand this one. If I say any matrix A, any matrix can be also assumed as the actually bunch of columns. Like 3 columns means the column 1, column 2 and column 3. So if a 3 by 3 matrix, I can say this column 1 has 3 elements, column 2 has 3 elements and column 3 has 3 elements. So these are indicating C1, C2, C3 are columns. Now you also understand one thing, that if I have any matrix A and if I'm multiplying this matrix with the column of identity matrix, first column of the identity matrix, I will get the column 1 of the matrix A. How we can make sure? You can see it here. Suppose I have a matrix A, which is, let's say, A, B, C, D, E, F, and G, H, I. And I'm multiplying this thing with 1, 0. Let me write, otherwise the equation is will be incorrect. So, okay. So this I'm multiplying, let's say I'm writing like this, A, B, C, D, E, F, and G, H, I. And if I'm multiplying with 1, 0, 0, you notice what we get. It's just the first column, that is A, D, G. And now it is followed for every such column. It means in order to find out, so I'm writing A times, let's say, the second column of the identity matrix, that is 0, 1, 0. So this will give you column 2 of the matrix A. In the same way, if I have the third column, that is 0, 1, 0, 0, 1 of the identity matrix, I will get the column 3 of the matrix A. So this idea we can apply here. So how we can apply, you can see. You notice that this the first equation is A times 1, 0, 1, 1, 0, 1, and you multiply, the right hand side is given 2 times 1, 0, 1, so we'll give it 2, 0, 2. Okay, and the second equation it is given, let's say this is the first equation, and I have second equation. Second equation is A times minus 1, 0, 1, minus 1, 0, 1, and here we are multiplying perhaps 3, let me check, 4. So that will give you a negative 4, 0, 4. This is second equation. And let's say I have the third one, and third one I think there is no such change, 0, 1, 0. So 0, 1, 0, and this is 2 times, let me multiply this 2 inside, so we'll give it 2 times 0, 1, 0. So that is 0, 2, 0. That is third one. This is, let's say, the 1, 2 and 3, and let's say this is 4, 5 and 6. So from 4, 5, 6 to achieve this 1, 2, 3 is a little bit tedious task. Can we achieve this, any of this 4, 5, 6 from 1 to 3? It's easy. Why it is easy? Because you see, if I add this 1 and 3, I will get 1, 0, 1. You can notice. So what I'm going to do is, I'm just adding this 1 and 3. So if you add 1 and 3, I will get what? 1 plus 3. I'm getting A times, and you can notice here, what is the addition we are getting here? See, this 1, 0, 1, and this is 0, 1, 0, 0, 1. So if you add them, this A times, it will come 1, 0, 1, and right hand side we get C1 plus C3. So let me write it. A times 1, 0, 1 is equal to C1 plus C3. But you notice that A times 1, 0, 1 is already given 2, 0, 2. It means what I got is C1 plus C2, C3 is 2, 0, 2. Similarly, you can notice from there, if I subtract this C1 from C3, so this is 0, you can notice here, this is 0 here, and this is 1. So 0 minus 1, negative 1, 0 minus 0, 0, and 1 minus 0, 1. So you get this fifth one. It means now again I'm writing here, what I'm writing, that a times, this is going to be 3 minus 1. So a times, this is going to be negative 1, 0, 1 is equal to C3 minus C1. But you notice the a times negative 101 is given as minus 404. And this is the case. Now we can directly find out the C3 and C1 directly, means column 1 and column 3 for the matrix A. So if we add them, C1 and C2 get cancelled, and twice of C3, we'll get it here, negative 2, 0 and 6. It means the C3 I'm getting as negative 1, 0 and 3. And C1, to find C1, of course, I can substitute here the C3 value. So C1 is going to be 202 minus C3. So that is C3 is already found, minus 103. And we simplify, that will give you 3, 0 and negative 1. So we got the value of, the elements of C3, column 3, and the elements of C1. Now C2 is already given. If we identify this thing, that if I multiply A with 0, 1, 0, I get the C2. It means here already we have A multiplied with 0, 1, 0. So this must be the C2 of this matrix A. It means the matrix A directly we can write the C1. C1 is 3, 0, negative 1. And C2 is already I have 0, 2, 0. And the C3 is negative 1, 0, 3. Once we get this matrix A, I can find out A minus 3i directly. And once I get A minus 3i, I can find the determinant of A minus 3i, and we can make sure whether the equation, the system has a unique solution or no solution. So in this way, this matrix can be found by help of this concept. Alright, so that's it for today. See you in the next video with some other JEE Main questions with some other different solutions which are smarter and quicker. Till then, stay math active.